This is tutorial 1 question 10. In this question, we are given E1 and E2. These are the standard basis. E1 means traveling 1 unit along the X, no unit along the Y, so we have the X direction. E2 means no unit along the X, 1 unit the Y, we are traveling the vertical direction or the Y direction. The transformation of E1 will give us Y1. The transformation of E2 will give us Y2. This is given. The technical terms is the image. The image of the transformation of E1 is equals to Y1. The image of the transformation of E2 is Y2. Now, find the image of this input. So we want to find t, 5, and minus 3. So t is now an abstract linear transformation. But we know that all linear transformation can be mapped into a matrix multiplication. So this is the standard matrix of T. We want to represent linear transformation as a matrix. Calling it the standard matrix. And then so that we can do 5 and minus 3, and then quickly we can find the answer. So the question is, find the standard matrix of T. There are two ways to go about it. Let's do the simplest way first. Transformation given a matrix is this guy, 2, 5, which is the image of the E1, minus 1, 6, the image of E2. The transformation matrix is exactly transformation E1, transformation E2. So in fact, there is nothing for us to do here. He has already given you this standard transformation matrix. We put the transformation matrix here, multiplying it with the given new coordinates that we want to play with. And then now we can do matrix vector multiplication, and this is the answer. What about if we use the definition of linear transformation? Remember that we are interested to find 5 and minus 3, the input. 5 and minus 3 can be represented as 5, 0 plus 0 minus 3. But this also means 5 times 1, 0 plus minus 3 times 0, 1. This also means 5 E1 minus 3 E2. So therefore, we have just basically represented 5 minus 3 in terms of the standard basis E1 and E2. Now, linear transformation says that, alright, we take the input and we can decompose it into the standard basis times some scalar. Because it is linear, it allows us to bring the t operating onto 5e. We can break the input into two parts. We can do it separately. The first one doing for E1, the second one doing for E2. Linear transformation also says that t of 5E1 is 5 times t of E1. So that's the definition of linearity. One of them, the property is the scalar multiplication property. We can bring the scalar outside the transformation. So remember that we are given t of E1. T of E1 is 2, 5. So basically we do 5 multiplied by 2, 5 for t of E1 minus 3 multiplied by t of E2, which is minus 1 over 6 given above. So then we just open up to do the usual scalar multiplier of the column vector, and we get this. So this is exactly equals to this. I prefer the second method, using the definition of the standard matrix. Basically, the first column is the transformation of E1, the standard basis. The second column is transformation of E2, plugging it in, and then we get the standard basis. But maybe method 1 gives you a clearer insight why this is true. Thank you.